Okay. Wow. Well, thanks for coming today to this webinar, which is part of the 30 Years of Globe webinar series. Today, we're going to be talking about the surface temperature protocol, and we're going to be hearing from Dr. Kevin. Oh my goodness, I should have asked you this before. How do I pronounce your last name?
Oh, we say Czajkowski, but I just go by Dr. C, so that makes it
Dr. C.
easier.
Yeah, that's a tough one. There's lots of
Yeah,
letters in that.
yeah.
Okay, well, so Dr. C is based at the University of Toledo, and he has a wide range of interests in all types of geospatial technologies. And I am just so happy to have him here today to talk to us and to learn from him. And so I'll hand it over to you.
All right. Well, thanks. Thanks, Brianna. Okay, so yeah, I'm going to share my screen. We'll do the presentation on surface temperature, which is the protocol I developed for Globe. Hmm, what do we got going on here? There we go. That looks better. All right, so my title is Globe Surface Temperature Protocol, Development of a Unique Data Set to Study the Earth. And it's part of the 30-year anniversary here of the Globe program. Although the surface temperature protocol is only 23 years old. So we're not, it's like kind of the second wave of protocols that were developed. Just a little bit about myself. Yeah, I grew up near Buffalo, and everybody knows Buffalo is known for snow. In 1977, the Star Wars movie came out, but also we had a blizzard in Buffalo and called the Blizzard of 77. And well, anyway, we missed school for a week and I thought that was the best thing ever. So that got me really interested in meteorology. I went to Oneonta, which is a small school in New York for meteorology. And then I went to the University of Maryland, Michigan for my PhD. I did my postdoc at the University of Maryland after that for 3 years, but then came to the University of Toledo after that, and that was 27 years ago. So I've been at Toledo for 27 years. And there's my wife, Kathleen. I have two sons, Robbie and Timmy. Robbie's doing his PhD at the University of South Florida. He's got one more semester at Lawrence Tech University. I make an ice rink in my backyard every year. But this year, I actually fell on my head for the first time. I've been skating, I don't know, for 50 years or so. I'm a really good skater, and I fell. Of course, I have different levels of my ice rink, so it's a little bit of extreme skating. So that's partly why I fell. But and then we have a dog, Coco. All right, this is where it all started. 1999. I actually got a new investigator grant from NASA to do surface temperature measurements and then compare that to satellite imagery. And there was this project going on called the Southern Great Plains 1999 or SGP 99 experiment. So I volunteered to go. I wasn't part of the experiment, but I said, all right, we'll go. And then I had a graduate student, Jim Koss, and he went with me. And you can see over on the left image, that is a $3,000 infrared thermometer from, 1999. That was our dog barking. So that was like a prototype. I didn't make it. I mean, somebody else made it. But we were able to borrow it to do surface temperature measurements. And then I put out hobo instruments. Somebody may recognize that. We put out hobo instruments where the real little flags are all over this farm field. It happened to have bulls and cows and everything in it. And so we weren't bothered by the bulls, but it was kind of exciting sometimes to walk through the field. That field study was to develop the sensor for NASA that was the soil moisture active passive satellite. So you can see how long it takes for NASA to develop a satellite. They were flying the SMAP mission on an aircraft at the time and flying over these farm fields. We did soil moisture measurements as well. And anyway, this is the start of it. So I had this idea, oh, if I could take surface temperature measurements, students can as well. And I applied to the NASA Globe program. The NSF had a call for proposals and had funding, and I think it was about $300,000 for 3 years. So we had the school well, and I bought the infrared thermometer. It's kind of hard to see in the student's hand, but I think it cost about $200 at the time, so it's better than 3,000. And that was in 2002. And we had the students come out. It was snowed. This was a Saturday. And this is the Arboretum for the University of Toledo. And my older son, what was he, like 3, 4 years old? So I had him on a sled, pulling him around in the snow. And the students, even though they're cold, they took the measurements and tested out the instrument. So then just some more information about how things transpired and moved on. Raytech was the company that was building the infrared thermometers at that time. They were about $160 then. We had to use GPS units. We don't have to use them now, right? We use our phone. But you had to buy a separate GPS unit to find the location. We had everybody take cloud observations because they're so important for surface temperature, as well as was the ground wet or dry, and was there snow on the ground? And we have, and we still should have, I don't think it's quite, I think it is there. Yeah, it's still there. You have to say if there's snow on the ground, and then you're supposed to measure the snow depth at each place you do surface temperature observations. And we figured out that if you take 9 observations, that gives you a good average. I was trying to find the data for that. We never published it. But what we did was we went out in fields with grass and stuff and took measurements up to 81 observations. Then we did the averages. We took random values. You needed 9 is like the sweet spot of where the average doesn't change. Like you could add more observations, but it doesn't get any better. If you have less observations, then it actually gets worse. So here's actually a news article from 2001. You see Terry Banco, who was helping us out. She had an infrared thermometer showing how to use it. What's the teacher's name here? My things are covering up his name. Oh, Jeff
Jeff.
McKenzie. Yeah, yeah. Jeff from, oh, it's Washington Local Schools in Toledo. And he's still a teacher there. And he joined one of the zoo projects. And Sarah may recognize his name from that. Anyway, that was cool. And actually, I found this slide I use all the time still, but I developed it for the first time in 2002. Explaining why do we measure surface temperature? Well, surface temperature is at the heart of the energy budget. You have the sunlight coming in, heats the ground, the surface, and then the energy gets broken into several things. You have evapotranspiration, a 17-letter word, by the way. Yeah. I always tell the kids, impress your friends and family with that word, evapotranspiration. Sensible heat rises. This is the heat we feel. And then energy goes to space and cooling the surface. That's our electromagnetic energy. And this is the energy that the greenhouse gases absorb, by the way. So, keeping energy in, warming the earth up. And I see how the ground energy is getting covered up a little bit in this figure when I transferred it over. Oh, okay, now I got my Okay, here we go. Now, we actually started working on soil temperature at the same time we were doing surface temperature as part of this grant for NASA. This data and study, it got published, but it never got incorporated into GLOBE. But what we did was we measured soil temperature with sensors at these locations at the Arboretum. This is the same place where we tested out the infrared thermometer. And the student, he did his master's degree on this. We used hobo data loggers again. And he measured at different depths. And you can see here's some of the data. The depth is on the y-axis, and it goes from 0 at the surface down to 100 centimeters, so a meter. And then we have the dates here, December 1st, 2002 through, was it April 19th, 2003. And you can see how the temperature changed, whereas like at the surface, it gets really cold. And then at 10 centimeters, it's much warmer, and then it kind of stabilizes. And what we had determined or figured out was that we should take soil temperature at 10 centimeters and then probably at 50 centimeters, because at 50 centimeters, it doesn't change a lot. And that would give you like kind of more of a seasonal change. Whereas if we do 5 and 10 centimeters, they're essentially the same temperature. It's not a big difference. So that was our outcome. Now, the study ended in like this April of 2003 because even though at the Arboretum we said, hey, don't mow this section where our sensors are, of course they mowed it and mowed up all the sensors, chopped them up, chop, 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 chop. All right, here's some data also longer term. Well, maybe it's some data still, sensor still, and maybe I'm wrong about when it was mowed. Let's see, we have July 10th. I know it was mowed after it somewhere in here, but let's see here. We got 10 centimeters changes quite a bit, and then 100 centimeters is a slower change. So it's 50 centimeters in between. So we're kind of showing that we want to look at this 50 centimeters. Now, this is in Fahrenheit, by the way. So just to take that as a thing. All right, so I'm going to change to, yeah, I'm going to cover a lot of stuff in this talk, a lot of historical things just for fun. I used to have brown hair, right? Now I don't. But we did webcasts from NASA Glenn. The internet wasn't that new at that time. And then Andrew Humphrey, he's a meteorologist still in Detroit. What was cool was he got his degree at Michigan. And then when I did my postdoc at Maryland, he had just happened to be in Washington, D.C. as a meteorologist. So I connected with him again. And then I moved to Toledo, and he happened to get a job as a meteorologist in Toledo. And then now he's moved to Detroit. But we started doing this education outreach together, and he would go with he was the personality. I was the, whatever, non-personality. But from NASA Glenn, we did these webinars. So they had a mobile unit, they'd beam it out over the internet. It was actually really stressful because I'll show it here. Like the one webinar, we had 134 schools signed up, over 3,000 students watching this webinar. I mean, that's impressive. And I think I brought home. Let me try to find it. Uh-oh. Okay, I should have found it before oh, here it is. Aha. I have one of the tapes from 2002. So this is a recording of that webinar. So we did about 6 webinars at the time. Like I said, over 1,000 students per webinar. It was really impressive. And you see the distribution by state. Anyway, had a lot of fun there. Okay, let's switch to the next. Okay, Iowa. So this is the Globe One was in Iowa. Some people may hear of Globe One. It's a historical thing. Marcy Seavey hosted it. It was kind of like this. Let's see what the date, 2005. All right. We're kind of like, okay, what do we do with Globe? Globe's been around for 10 years by that time. Surface temperature's only been around for 3 or more years. So I worked with schools in Iowa, and you see all the different schools here, and these are the temperatures. So let's see, they did this April and then May. You can see the different values. There's kind of a gap there for a number of days. Sorry about the formatting of the date. This is the old days of Excel. So it was harder to format dates at that time. All right, let's see. Oh, and then we were trying to connect it with satellite overpasses. Now, this is Landsat in particular. This is important because as I was reviewing this stuff, I was like, oh, yeah, we should do this again because we haven't done this in a while. We should do some science with this stuff. Here's one example. We have this Hoover Middle School in Iowa, and they have their football field. They did prairie measurements in their bus circle. And so this is the Landsat image. You can see orange is warmer. So the school itself is warmer than the surrounding area and the neighborhoods. And then the sports fields are cooler. And what we did was we had the temperature in Celsius. The globe is the student temperatures, like the bus circle, 29 degrees Celsius. Landsat was 23.3 degrees Celsius, so it's lower. And then here we have the football field, 30.3 degrees Celsius, Landsat 22.7. And then the prairie, 30.8 degrees Celsius for the students and 23.8. And of course, then we used it for why is the satellite cooler than the student observations? Well, it's because of the atmosphere. So the satellite is getting energy from the atmosphere as well as the surface, where the students are at the surface. And this is a great way for using the student data to correct the satellite imagery for the atmosphere. And this is always pretty much always the case. Now, the other thing we realize or find is that in many communities, the hottest place is the school, especially in rural communities. So you'll see this over and over with Landsat imagery. The schools are hot. They're emitting energy, especially in winter. The insulation's not good. It's roofed. They have big parking lots. Now a lot of the schools have artificial turf. We'll get into that later. Oh, here's our scale. All right. So something else we looked at was the tillage practices on farm fields. And so some of my team who are listening now, let's put it in our brain. We should do this. This would be a good research study still, because it's not known. How do farm fields and farming practices affect the temperature of the surface of the earth? In this case, let's see, we got here. The no-till farm field was cooler by about 3 degrees Celsius than the conservation tilled field. So conservation tilled means they till a little bit. You see how the corn stalks are knocked down and they're mixed into the soil. And then no-till means they haven't tilled it at all. One thing we haven't really looked at is traditional tillage, what I think is even hotter, would be a warmer surface. So here we go, conservation till, no-till, and there's our data again. All right. All right, so around 2012, the surface temperature has been around for about 10 years in globe. I don't know how it came about, but finally got the idea, well, let's have a campaign to try to get more people taking observations at about the same time. So that's when the surface temperature field campaign came about, was about 2012. And we decided on October, December, and March as our months. Now we haven't even changed that to today's date. Oh, hang on. Where am I going? All right, messing up. There we go. We'll go back there. Okay. Now in 2015, we looked at El Nino a little bit. And then in 2017, it turned to the urban heat island campaign with urban heat island slash surface temperature campaign. So even like before 2017, urban heat island wasn't really talked about much, I don't think. So that's when we started talking about it. But people really didn't even embrace it. And I've thought about, well, let's stop the urban heat island campaign. Now it's been changed to an intensive observation period in 2023 because that means something different in the globe definitions. But I thought, well, let's stop it. But more and more people keep doing it because urban heat island now is like this really important topic, right? And heat stress and all over the world. So we were kind of ahead of the curve by doing this like, starting over 8 years ago with the urban heat island. All right, so here's more about what we were doing. We use this slide to show October, December, and March. We have focused a little bit on July, especially when teachers are doing stuff. Sometimes, okay, and this is another thing I didn't find was how do the IRTs get affected by going when you take them outside? And they go through thermal shock, or they can, if the temperature is much different outside than inside. So we had done studies many, many years ago. We had at the Lake Erie Center for the University of Toledo, we have a freezer that you can walk into. So we would actually experiment with that, knowing the temperature of the freezer inside and how long does it take for the infrared thermometer to get off and be inaccurate? So it really takes about an hour if you're going to leave it outside. But also that's where the oven mitt came in, is you can put the oven mitt around the infrared thermometer. Now, when the infrared thermometers got smaller, like grab one here, these E-Tech City ones are smaller. It doesn't really work with the oven mitt. So sometimes better just to leave them outside in the shade, of course. If you put them in the sun, then they're getting cooked. You get thermal shock as well. So that's one of those things that's kind of weird about surface temperature is if the instruments go through thermal shock. Now, if you go outside, you take the measurements quickly, boom, 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 boom. It's before the instrument goes through thermal shock. This kind of like takes about 15 minutes to go through this, getting air. Now, I just wanted to share some other images. This is Matt Fenzel. People know him as a Globe alumni. And he was in India. We went to India, of course, for one of the GLEs, the Globe Learning Expedition. And he was showing the student how to take surface temperature observations. And oh, India was hot. So that was something. We went to a park and we had different groups and people went around and we took a lot of surface temperature measurements with that. Wanted to show this picture. This is from the e-training. That's my youngest son, Timmy. So he was my subject when we made the e-trainings. And Sarah, who's on the call here, she made a lot of those e-trainings with me. And anyway, he's now 21 and over 6 foot tall and whatever, he's grown up a lot. But, it's good. Memories you see, you get the kids helping you out. All right, some more data. Let's see. I knew I put this in. Okay, so this was with my kids' school. So this is Ida High School and middle school. And the kids took a lot of observations. This is one day. So that's the time on the bottom, universal time, the temperature in Celsius, and obviously there's snow on the ground. I mentioned the snow depth. There's asphalt with no snow. There's asphalt with 20 millimeters of snow. There's concrete, no snow, concrete with 20 millimeters of snow. And of course, my thing's in the way again. The grass had 130 millimeters of snow in the softball field. The softball field had 130 millimeters of snow. And you can see that the difference in temperature. The asphalt and concrete was above freezing, but the snow-covered areas stayed below freezing. So that was pretty cool, especially like the softball field. The grass was, negative 12 degrees Celsius. Pretty chilly. All right, so here's went to Europe. Oh, what year was that? 2012. Got to do a globe trip in Europe. We got some of the driving here from Marcus Oyster's house in Switzerland. We stayed with him. Went to Constance, Lake Constance, a great group of students doing measurements there, like every day all summer of their lake. And then we drove up to Cologne to Carl Schneider's house at the University of Cologne. Here's my wife taking surface temperature measurements in Germany. So what a great trip that was. And we learned some things though. In Europe, they have a lot of these paving stones for the roads, and the roads aren't hot. In the US, the roads are really hot in the summer because it's solid asphalt, solid concrete. But these paving stones, they have like the mortar between them, and it must let moisture out of the ground and cool air out of the ground, and it keeps the pavers cool. So that's something we learned. Of course, this road down here is actually asphalt, but a lot of the roads in Germany are these pavers. All right, so now I'm switching to how has the data changed over, I don't know, last 20 years? No, not 20 years, 11 years, sorry, 11 years. All right, 2014 to 2024. So the number of sites people have taken observations from is on the left graph, and the number of observations is on the right graph. So let's see. The sites is, you define a site, you take your observation. 2014, we had less than 200 sites. So that means there's less than 200 schools involved. 2020, we had the pandemic, so we had a little bit decrease in the number, but 2021, it went up to 1,200. There's a big jump there. Can anybody guess why? Why did the number of sites jump?
The app?
The app. Nice, Brianna. Very good. Yeah. And not necessarily citizen scientists, but teachers and students using the app. You can create a student account and then use the app, right? So that's exactly right. And that, multiplied the number of sites. Now that's gone down a little bit. And you see as the data, it peaked in 2019. It's kind of gone up and down a little bit, but 20,000 observations as part of our field campaign. I think is pretty impressive because these are all taken by hand. And this is not including like if one observation includes 9 points, right? Now, not all of them are nine, some are three. Let's say you do an average of five. This is 100,000 data points. Pretty cool stuff, I think. So I'm really impressed with this. So totally over the whole time we've done surface temperature over the globe, 5,480 different unique sites, 260,000 observations. And again, that does not include like the 9 points. So that's over a million data points. Okay, so I really need somebody to do more research using the data. So that's one of our challenges. Okay, so moving into like the latest history. Um, we've been doing this, of course. I didn't have funding for many years, so my wife is sitting next to me now. But I would tell her, I didn't tell her I could take vacation this summer because I wasn't getting paid to do this globe stuff. But we would train teachers and Oh yeah, she has kind of this, grumbly face. But it's all good. Ultimately doing this globe stuff and the surface temperature turned into a NASA Science Activation grant in 2016. And it's a big grant. We've been working all over the United States. Now it's unfortunately it's mainly the United States. We can work with schools in the US. And we got it re-upped in 2021, and then it's going to end here in December. We're hoping the program can continue, but we'll hope for that, right? All right, so here's our Globe Mission Earth partners. University of New Hampshire, Boston University, Palmyra Cove Nature Center, NASA Langley, Tennessee State, Xavier University, WestEd, and UC Berkeley. And then there's other partners that, we have lots of partners. But these are like kind of the main ones that working all the time. And then this is our reach map in the US. We make this, Eton, who's on the talk, she makes this reach map for all of science activation, but she also does it for us. And these are the people we reach, the schools and the teachers. Now, I wanted to show this is where surface temperature has been taken since the beginning of globe, or surface temperature in globe. You can see it's in a lot of places. Lots around Ohio and Michigan, where I live, in that, all the teachers we worked with. Ireland, I'm going to show school program with Ireland. So you look at all those measurements in Ireland. You got the Netherlands had a school program. Croatia has been really involved. Poland, Estonia, Greece. So go Greece. Israel, Saudi Arabia, Nigeria. Femi has been very involved. Femi is now a graduate student of mine at the University of Toledo and will finish his PhD soon. India and Thailand, Taiwan, a little bit of South Korea, and then the Southern Hemisphere. It took a little while for the Southern Hemisphere to get involved. Of course, Argentina, Brazil is a newer globe country. Colombia, we've had teachers from Colombia participating. And the Canary Islands. I don't know why, but there's somebody in the Canary Islands doing lots of observations. The bigger the dot, the more observations for individual locations. So some of these locations have lots of observations, especially Saudi Arabia, the Canary Islands, Croatia. And then here's something you can do. You can compare the surface temperature from the students with satellite imagery. And I believe this is for the solar eclipse in the US. Yeah, last year, April 8th, you can see the totality went from Mazatlan in Mexico. We had someone taking surface temperature there up through Texas, Ohio and Michigan, New York, into Quebec. So this data has not been analyzed yet, so we want to take a look at it. I want to actually look at how does the solar eclipse affect surface temperature in urban heat island. Thought that might be of interesting twist on things. I'm going to go over a few projects now. The first school project was, let's see here, Maria in the Dominican Republic said her students, all their playgrounds were asphalt. The Minister of Education wanted everybody to be basketball stars from the Dominican Republic. Well, the kids said it was really hot. It's a tropical country. Why you have asphalt? So the kids painted different colors, and they found that green was the best color to paint their playground. So that was pretty cool. And this was like prior to any research on painting pavement, which now is very common in the United States to do research on that, and they're starting to actually implement it. Let's see, Ramona in Malta is, well, mess it up again, having her students take observations, which is interesting. My father-in-law's from Malta. So when my in-laws were going to Malta for a trip, I gave them some infrared thermometers, these Fluke ones to take, and then they're still using them in Malta, which is really cool. And it led to partly this campaign, I think. Paul Pace is the professor at the University of Malta that originally got the infrared thermometers. And then Malta led this project with Ireland. I mentioned Ireland being very involved, Malta and Israel, and they had this great communication and the students sharing over, the internet what they did. I participated, of course, all the meetings were at like 4 a.m. Eastern time, so I had to get up pretty early. But it's really cool to see the students doing their projects. Here's the students in Ireland measuring grass temperature. Let's see. Oh, okay. So I've been working with Vasco Montes from Portugal on sports fields. We're looking at how hot are sports fields with the artificial turf. Well, it turns out they're really hot. So here's our campaign flyer that we have made up for the sports fields. Had people looking at them. Here's our flyer from this year. We have David Bidlowski's grandson here, Justin taking observations. And it turns out the sports fields are the hottest surface that there is. So let's have our children play on these hot surfaces and, get heat stroke and stuff. So anyway, this is a playground in Israel, and this measurement was taken in March. The surface was 70 degrees Celsius. That's super hot. And why is it so hot? I don't know. It's plastic. It has the black rubber tires in it. Maybe that's so hot. I don't know. All right. So, okay, other things we're doing, working with the city of Toledo on urban heat island. And Beatrice, we got the NOAA in the United States does a program called CAPA, and they help cities study their urban heat island. So we combined GLOBE with this NOAA program, and we mapped the urban heat island in Toledo. But we also mapped the trees. So I had my students map the trees. And now the city of Toledo got a $6 million grant to plant trees in neighborhoods that don't have a lot of trees to try to cool them down. And this summer, we're going to have students going around and studying a specific neighborhood. I hope to take globe observations. So we just learned who the teachers are doing this yesterday. I think we learned who the teachers were doing that. Sarah developed this urban heat island effect for students webpage or Google site. So here's the website for that, and has all the resources, videos of students doing stuff, how to do everything, how to do a project. Yitong made a story map with Midstory, which is a nonprofit in Toledo, on the urban heat island in Toledo. And here's where we learned that the University of Toledo is one of the hottest places because of the artificial turf fields and the parking lots. So we talked to people at the University of Toledo. It really hasn't changed anything. So it'd be nice if we could change something. Now, NASA Langley, an intern there, Alan, and one of my students, Tamina, have worked on a Google Earth Engine app to get Landsat images, and you can do this anywhere in the world. Yeah, okay, it's at the bottom is the link for that. This is really cool. This is like the holy grail. I've been trying to do this for 25 years. You can look at urban heat in about 3 minutes anywhere in the world for data for the last, I think it's about 8 years. I mean, that's pretty cool. Here's Detroit. You can see the urban heat island for Detroit, Windsor, Ontario, in Canada. NASA Langley made a story map for urban heat island. Yeah, all these things happen. I didn't do it. But I think people did this stuff because the urban heat island was a campaign in Globe, right? So it's just really cool that people put so much effort in, but there's so many resources for this. And of course, it's such an important topic nowadays. And they use the 5E learning model: engage, explore, explain, elaborate, evaluate. They use pictures. I helped out. And actually, I did some of this. I helped out provide some pictures and data for the story map for NASA Langley. All right, here's another thing. The Aaron project, which is another science activation, they have the Terra rover. The Terra rover has an infrared thermometer on it, takes temperature we can use for urban heat island studies. And here's our study of the football field at the University of Toledo. It's called the Glass Bowl. I don't know if you can see this. These are values. Each is a dot. So the Terra rover drives, and so the dots are so close together you can't tell they're dots. But blue is cooler, red is hotter, and you can see even on the asphalt parking lot it's blue versus on the artificial turf football field it's red, right? So it's so much hotter. And then over on the left, or right here is the soccer field. Again, the soccer field's hot, artificial turf. The asphalt and concrete are cooler. Something to just be aware of. Of course, the grass is even cooler than the asphalt and concrete. So wouldn't it be nice to have natural grass? All right, I'll continue on with crazy stuff. This happened Monday. We launched, we call it's Stella. Now, Brianna was asking me about Stella a little bit ago. This is the inside of Stella. Stella is a spectrometer that NASA, I think it's NASA Goddard, Mike Taylor and Paul Morrell developed. So my students and students from Toledo Technology Academy, Crestwood High School, and Stockbridge High School took the instruments from Stella. We made a printed control board, which I didn't even know what that was before we started this. Put it on in this box and launched on a high altitude balloon. On Monday, it went into Indiana and then got stuck in a tree. Even though it was farm fields everywhere, it found a tree. But the electric company got it down out of the tree yesterday, and I'm going to go pick it up in a few days. So we put Stella in space, but Stella has a thermal sensor on it. So we're taking the temperature along with the spectra, which we can then do the urban heat island study with. Very cool stuff. And then I'm going to show, well, what we want students to do projects with this stuff. And why do we want students to do projects? Well, because this is what the scientists do. This is AGU, American Geophysical Union meeting. This is in San Francisco. Every year, like 25,000 scientists go to AGU. And I go every year. I've gone since 1980, no, 1990. So that's that, 35 years. That's a long time. So anyway, so we want students to present like that. So we came up with students presenting. Brianna was mentioning the Satellites Conference. We used to call it the Satellites Conference. That term was developed by a second grade teacher in class. Students and teachers exploring local landscapes to investigate the Earth from space, I think is satellites. Been a while. But anyway, we started that and we started having students present their projects. We have kindergartners here in the middle. They're really smart kids. And they're looking at air quality. So anyway, and then students went to the White House. So we had 3 groups of students go to the White House for the White House Science Fair. Pretty cool stuff. All right, so I'm going to show you some of these projects. All right, okay, there we go. Something like that. I'm messing up all the controls again, sorry. We have the chat and all that good stuff I was trying to look at. All right, so here are some projects students have done. Sandusky High School, which area of the zoo is coolest? So they're looking at the Toledo Zoo, I believe, and finding the primate forest was the hottest. The Tembo Trail was the coolest. I don't even know where Tembo Trail is. On the right here, this is a University of Toledo student project. So I have my undergrads do projects. Actually found out yesterday also that one of the students that took my class then worked with NASA Langley and is part of Globe through NASA Langley in Toledo. So that's a pretty cool connection. The student remembered doing this stuff with me in my class. So the asphalt is hotter than the grass. It's not always the case, but in a sunny afternoon, it is the case usually. All right, so here we go. Here's another project from Crestwood High School. They used the Aaron project as well. I did the track. See the data on the bottom. Very nice poster there. Here's some more Crestwood High School students. They're looking at tree attributes in the temperature. Pretty cool stuff because trees cool the surface. Here's students from Freeport High School in New York. Their project. All right, so we had students look at the solar eclipse. Now, I only included one. We have a lot of solar eclipse projects using surface temperature. And the surface temperature goes down, you can see in the central graph here, more than the air temperature. And that makes a lot of sense, right? Because I showed in the beginning, the sun heats the surface heats the air above it. So when the surface temperature cools in the evening first, then the air temperature cools. This is how the things work. And you can see that in a microcosm of the solar eclipse. All right, here we have, another undergrad looking at temperature over a single day. Oh, using the library. Yeah, so orange. So during the solar eclipse, we had a lot of data taken by students, but also by libraries. So I trained the librarians as teachers. And this kind of getting at the concept of, can we have citizen scientists do this? At the moment, you still have to be trained some way. Libraries can work as a place for citizen scientists to do it because then the librarians can be trained as a teacher, educator, And then they can give out student accounts to the citizens. All right, so that's one way of getting citizen scientists involved. So let's see, Buckeye Central Local Schools. We have some, I think these were teachers, but I'm not sure
Yeah,
because
they
we
were.
always have, oh yeah, thanks, Sarah. We always have the teachers do projects. We want them to be comfortable with doing the project before we have the students do the projects. So they're looking at their own school. All right, I'm going to finish up with this. I just went through the 23 years of surface temperature, but these are some things I would like to see us do more with the data. The question is how. How do you even get funding? There might be with the citizen science program, we might be able to get some funding to fund people or grad students to look at the data, but we have a ton of data from the solar eclipses. How does the solar eclipse affect the surface temperature? And we have published one paper on that so far. I'm hoping to publish more. And then getting back to the connections with Landsat and the satellite imagery, originally the surface temperature was used to adjust or validate the satellite imagery temperature. You know, does there need to be more research on that? I don't know, especially for atmospheric correction. Let's see, did I even put down? Oh, I wanted to put down the whole part about farm fields and tillage practice. How does the land cover of farming affect the temperature of the earth? And then continue with urban heat island and how have urban heat islands changed over 20 years. That should could be cool. I want students to keep taking observations, and then you see there, can we get more citizen scientists involved? I mentioned the libraries. Libraries is one approach, but maybe there's a different way. Maybe it's time for the app to allow citizen scientists just to do surface temperature. All right, there we are. That was my presentation. Everything you want to know about surface temperature.
Wow. Thank you so much. That was really interesting and like pretty fun to see all the directions that something I don't actually, to be honest, like I'm gonna admit it, I don't spend a lot of time thinking about surface temperature. And now I'm like, wait a second, why? Maybe I don't spend enough time thinking about it. Like it's kind of pretty cool. It's pretty cool, and it's pretty cool how it connects to all different things. So, yeah, thanks for sharing that. I'd like to open up the field for any questions that people have. I also have innumerable questions, but yeah, does anyone have any questions they'd like to ask? You can unmute yourself and kind of just go ahead and ask it if you have one.
Hi, Kevin. This is Herb. Can you guys hear me?
Uh, yep, hello.
Yeah. So I see, you guys using NASA data a lot, and I really am curious to hear more about how NASA is using your data, because it seems like sometimes it's a little bit too much one direction. And like you said, initially the idea was, for validation, calibration, but I think that NASA scientists forget about GLOBE, in my opinion, too often. So just if you can share any stories or any recent developments, be happy to hear it.
Well, for the surface temperature, I don't know if any NASA scientists are using it. Now, the Langley people have used it for educational purposes, for the story maps, etc. Now, I've done more with the globe clouds and snow data. I used to work with Dorothy Hall at Goddard on that. Now I have worked with Brown de Colston. What's his first name? Oh, nobody knows.
Eric.
Matt. Oh, Eric. Yeah. Eric, thank you. At Goddard as well on land cover. But yeah, I don't know that anybody's used surface temperature. Okay, well, okay. See, I remember stuff. You talk enough, you remember stuff. Now, Lynn Chambers used the infrared thermometers to measure humidity in the air, and that's been published. So it's not necessarily the globe data itself, but the kind of the concept of using these cheap infrared thermometers. And it's just some science technique, but for NASA research.
I was
Um,
curious. Oh, sorry, just one quick
yeah,
question.
yeah, go ahead, go ahead.
Uh, building on Herb's question, have you ever looked at the temperature data that you and the students have collected in conjunction with like the EcoStress mission data? That's on the
I'll say no. Now,
okay.
Eric and I put in at least two eco stress proposals to get funding to try to do that, but we were never funded.
Hmm.
Yeah, so we've tried. I've never had funding to actually look at the data, right? So anything we've done is like maybe a master's student doing something for a thesis. And as I mentioned, in many, many years, I didn't have any funding at all to do even education outreach with teachers. I just did it for free. Sometimes we got like the Globe office had like $2,000 or $3,000 grants I could use for equipment for teachers, but no funding for people.
Yeah. If I can jump in, so
Mhm.
maybe a little bit introduction by myself. So Kevin, I saw yesterday at another meeting. So my name is Xia Cai. I'm the program scientist of NASA developed program. I don't know how many are familiar with that program. We also, headquartered at Langley. So, I heard about Langley a lot. And of course, we have a globe office there. And also, this is pretty answer to a question for Herb and also try to answer some like future directions from Kevin. So NASA developed, we are doing more than 50 projects every year. So we're always looking for project ideas. And of course, trying to use the NASA data and other Earth observation to answer questions from communities. So we work with communities a lot. One big request is urban heat project. So we get a lot of requests from the like a non-profit or municipal government office. Want to say, can you help us look at urban heat island so we can put more trees or maybe more to like put like a wide roofing. So we get a lot of requests. And recently we are connected with Amy Chen, ask us how we can incorporate globe data to our projects. So as I mentioned about, we do projects across whole Earth, and urban heat is one big request. Right now, we have a 3 urban heat project in the summer, which the date is from June 2nd to August 8th. So we have 3 urban heat projects. One is in Treasure Valley in Idaho. The second is Overland Park in Florida. And the third is Davidson, North Carolina. So typically our participants, kind of students, we don't call them students because we have participants coming like graduates or like veterans or like a professional transition, early career professionals. So typically we use land surface temperature from Landsat for daytime temperature, and also use EcoStress for nighttime temperature.
Mhm.
So our strength is using satellite data and
Mhm.
put in a GIS. Our weakness is want to incorporate more ground-based observation. And because when we show the partner, the temperature is 115 Fahrenheit, they don't believe it. Said, is that high? It is high if you can, for example, like Kevin showed, if you have a local measurement from the impervious surface, like parking lot, it is 115. That show some confidence about satellite data. That means they can trust the pattern from satellite data. So I think for the summer project, I do want to encourage the team to use the globe data. I already look at data. It seems like for the Overland Park in Florida, they have a high school nearby. I think the data all went all the way back to 2012. So I want to encourage them to use it, and I can share what they found with you after the
Mhm.
after term finish. And also, I know, Kevin, you work with the partner a lot, right? If you have a project ideas, we are happy to work with you, to answer the concern. And also, we can use the historic globe data and make a good story. I think,
Well,
when we have a good story, that is good for both globe and also for develop. Yeah.
sounds good. Thanks. I know we just met yesterday and
Yeah.
we graduated from the same department at Michigan.
Yes. Yes. That is surprising. Yeah.
Yeah, and I think like building on what you were saying, like part of the strength of like using handheld sensors and like taking the globe measurements on the ground, I think even from perhaps a partner perspective, is they understand taking a temperature more by hand than they do by satellite. And so they can go, and the other thing is the satellites have times that they're there. EcoStress is cool because their overpass time is variable, but with Landsat, you're having very consistent time, and that doesn't capture all of the temperatures that someone standing in that place would necessarily experience. So it would be, I don't know where those students are located or, if the partners could find a student group, but it would be really neat if someone locally could help like the project by collecting some data for Globe in the temperature sense and then give it to the students. And so even though it doesn't have the temporal depth, it does have the temporal depth in terms of years, it has way more temporal depth in terms of the time of day and how real people experience heat in a location. So that would be like, I think, way too cool to combine everyone's strengths into like some kind of awesome urban heat, learning activity. Wow. Well, so thank you for all of this excellent participation and conversation. I am aware that a couple of you have a very cool sensor workshop to attend. So I think I will end the recording here and just say thank you again for participating. And yeah, maybe let's stay connected. Thanks a lot. See you guys soon.
Thanks, Brianna. Thanks, everybody.